So, last week we learned that pH is related to the concentration of H plus in solution, and we learned that you can easily calculate pH with a simple equation. pH is equal to negative log of the concentration of H3O plus. And we also learned that you can find the pH of a solution, whether it's an acid or base, just by finding the concentration of H plus in the solution. For example, if this is a 1 times 10 to the negative third molar solution of HCl, you can dissociate it to find H plus, and then just plug that right into our equation to find pH. If you're doing it with a base, it's really easy to find the pH by dissociating. Let me change the color. By dissociating your base. We're not really worried about the Na plus, but we are worried about the OH minus. And since you can't plug this directly into the equation for pH, there's a couple things you can do. You can find H plus or H3O plus from OH minus by simply dividing the Kw by the OH minus, and then you can plug that directly into pH, or you can find the POH, which is equal to negative log of the concentration of OH minus, and then you can find pH by subtracting the POH from 14. Today we're going to go the other way. Today I'm going to show you how to calculate H3O plus and OH minus from pH. And the equation is really simple. It's kind of taking the opposite of the negative log. So if square root is the opposite of square, and so on and so forth. So if you know the pH and you want to find H3O plus, it's real simple. H3O plus is equal to anti-log of the negative pH. And just like anti-log of the negative POH would give you the concentration of OH minus. So let's try a real quick easy one, and then I'll show you how we're going to use this one. Let's say that we have a pH of 2. Let's make it something a little bit more involved. pH equals 2.5. So we want to find the H3O plus, which is synonymous with H plus. We're simply going to plug this into our equation. And we're going to say anti-log of negative 2.5. So here's what it looks like on your calculator. Let me make that bigger. And let's make this smaller. Okay, that's better. Sorry. So let's plug this into our calculator, and what we're going to do is we're going to say, since pH is equal to anti-log of negative pH, and in this case the pH is 2.5, what we're going to do is we're going to say anti-log. So here's the log button. Anti-log is going to be the shift function, 10 to the x. And we're simply going to insert negative 2.5, and this is going to tell us our concentration of H plus. It's going to write it out in long form, 0.00316. If you want to leave it like that, you can. If you want to put it into scientific notation, 3.16 times 10 to the negative third, you can even round it to 3.2 times 10 to the negative third. Okay, let's try the kind of question you could expect. Okay, so here's the kind of question you can expect me to ask. It says, what is the concentration of a solution of HNO3 with a pH of 3.5? So a couple things that we could do. We could start off by finding the H plus, or we could start off by dissociating the HNO3. Either step, it doesn't matter what order we do it. I'm going to start off by finding the concentration of H3O plus. So H3O plus is equal to anti-log of negative pH. So we're going to say anti-log of negative 3.5. Let's plug this into our calculator, and we're going to say, all right, anti-log negative 3.5. We get concentration of H3O plus that is, well, pretty similar to the last one, but that's all right. 3.16 times 10 to the negative 4, and the calculator has cheerfully put this into scientific notation for us. 3.16 times 10 to the negative 4. It's because they both added in 0.5, that's why. All right. So if we're trying to find the concentration of the acid that produced this concentration of H+, here's what we know. We know that HNO3 is an acid with only one hydrogen. So if our concentration of H+ from this solution is 3.16 times 10 to the negative 4, it had to have come from this source. So the concentration of HNO3 that produced it, 3.16 times 10 to the negative 4, because these are both 1 to 1. Let's do one more. Let's do this from a base with a concentration, something that we can do from OH minus. Okay, here we go. This one is asking us what's the concentration of a solution of strontium hydroxide with a pH of 11. A couple things that we could do. Since we're trying to find OH minus in this one. So a couple things we could do. We could take our pH and plug it into our equation to find H3O plus. It's equal to anti-log of negative pH. And you don't really need a calculator for this one, but we'll do it anyway. We'll say anti-log of negative 11, that's our pH, and we get 1 times 10 to the minus 11th. Now, we could find OH minus a couple different ways. We could say, all right, since we know H3O plus, we can find OH minus by dividing 1 times 10 to the negative 14 kW by 1 times 10 to the negative 11th, and that gives us 1 times 10 to the negative 3rd. Or we could use this calculation to find POH. It's equal to 14 minus pH. So if we take our pH, which is 11, and plug it into this equation, I was thinking ahead there, 14 minus 11th, we get 3. And then we could say that OH minus is equal to anti-log of the POH, negative POH. So we'll simply plug this in and say anti-log of negative 3, and of course we get 1 times 10 to the negative 3rd. Notice how these two answers are exactly the same. So it doesn't matter how you do it. What is the issue is the fact that strontium hydroxide dissociates into strontium and 2 hydroxides. So here's where we gotta be careful, because we know that the concentration of OH minus in solution is 1 times 10 to the negative 3rd. It's already there. All right, it doesn't matter what put it there. That's how much OH minus is in solution. Our concern is this guy. All right, we've got this coefficient of 2. What that means is whatever produced this concentration of OH minus was producing 2 OH minuses, 2 hydroxides every time it dissociated. So we want to be careful because we're trying to find this. All right? This is where we run into some complications. So be careful when you're doing one like this, because we already know the concentration of OH minus, and it's already coming from a molecule that produced 2 of them every time it dissociated. So in this case, what's the concentration of the molecule that produced it? Exactly half, because it's producing 2 every time it does it. So if we have 1
teachers, please come to the main office. Mr. Claus, Mr. Nelson.
If we already know the concentration of OH minus in solution, we know that we were getting 2 every time the molecule associated. That means the molecule is producing 2 for every 1 molecule it has. Well, if you have 1 times 10 to the negative third molar hydroxide in solution, exactly half of that is the source of the dissociation. So 0.5 times 10 to the negative third, or 5 times 10 to the negative fourth molar is our concentration. All right? This is going to take a little bit of practice, so let's take it for a spin.